I'll keep a block at a distance on the platform. And this platform is going to rotate about vertical axis, passing through its center and perpendicular to plane. Let the block be at a distance, this one R, and this is rough. There are two persons are there. We'll appoint two persons. One person, let he be there on the axis. The other person is on the ground. The other person is on the ground. Like how we had inertial, non-inertial frame, that same idea I'm going to bring it here. This is the ground. Okay, now. And what we notice, the block is going to describe a circular path. It's going to go round about the axis. It's going to go round like this. It's going to describe. So what is this green color one? What is the green color one? Path of the, it's going to move in a circular path. Okay, let's ask the person A on the ground. And there's a person B who is at the axis. Time being, let me keep it axis. Later on, I'll change it. So now if the disk rotates, so what is the state of this platform? Platform, rotating platform. No need to go to physics lab when you eat breakfast or lunch. I think you'll be having a plate. No, most of the plates will be circular. Take that one. There in that open, you keep some vegetable similar to this as a block. I want paneer, you take it, or cheese, you take it, or take cut cucumber, keep it there on the plate, and start rotating the plate. For small angular velocity, that particular cucumber or paneer or this block, will try to swing along with the plate. As you keep on, as you start increasing the angular velocity, then it will start slipping. That's what we are going to analyze. Not big thing. So you must really put effort. This one. Okay, there's a block here. Now let's see that what actually happens here. Now the person B, notice that there's a friction acting on it. You notice that a friction acting on it. What person B says, the block is at rest and friction is acting on it. Block is at rest and friction is acting. And what it says, F non-zero, A zero. And so what is it? And what is the state of block? Block will have the velocity here. I'll bring omega in this sense. And this will be the angular velocity, tangential velocity. So the person what pen, the block or the person what pen, he will also rotate along with the axis. So what he says the block is at rest and friction is acting, F non-zero, A zero. What about person A on the ground? What will be its comment? What will be its comment? Block. And I'll move this here. What will be its comment? Block moves in circular path of radius r, and these comments are very important, and friction provides required centripetal force. Okay, got this. So you'll comment like this. So what is the path of the block according to person A? Person A, what he sees, the block is moving in a circular path. Okay, say that it is moving in a circular path. Then here there's a block. Then he says that the friction is acting, and it is having a velocity be like this. Now, who will see this path of block with respect to person A? Got it, no? He says it is moving in circular path. What about person B? He says it is a test. Okay, now what is the person A? You will write equation. You will just write equation only this one. You will write equation what? F equal to, it's there in SC Verma. This is one of the best way of entering into centrifugal force concept here. So you ask person A, why friction? You ask person, we'll ask him that one. We'll ask person A, why the friction is acting? We'll ask person A that one. Why friction is acting? He will say that I don't know all. Because of friction and tangential velocity, it is moving in circular path. This is where the disk is kept, the block is kept on the disk. These are the conditions. Some of you are asking that also. The block is kept on rotating disk. No, we'll ask person A, why that friction? He says that I don't know all. Friction will provide required centripetal force. Getting the idea? So the person A will reply only that much. Why friction means you say that person A cannot answer why friction is acting. We'll ask person B. What is the biggest problem with the person B? He says the force is acting, but still it is a test. He says block is a test. So what actually happening? The person B also will swing along with the block B because there are axis. No, he'll also be rotating. He'll also be rotating. Sir, what do you mean by rotating? We are not understanding. So he'll be rotating like this. Means all the time it'll be like this. So this is my mobile phone. This mobile phone is a block. That one, my palm is a person. So it'll be like this all the time. All the time what happens? The person, my palm will be seeing the mobile phone. So it'll be like this. Okay, got this one? So it's only rotating like this. Got this? So there's the idea of F equal difference. So person A will not say anything about friction. Why friction is acting? He says that I don't know all. Friction will provide required centripetal force. That's all. There's a very golden statement. You ask person B, why friction is acting? He says that block is a test, though friction is acting. I think there's a big problem is there, no? I think whose help we should take? Person B only. So what is the force acting on the block according to person B? Friction. But sir, force acting, then it should move towards center. No, the person B will not see any velocity. Are you getting all of you? Person will not see any velocity. Just see only friction is acting. So what is the force acting on the block according to person B? Friction only. He should not say net force 0. He notices only friction is acting. That's all. So there is something again, Newton's law has become invalid. No? To make it valid, what I should do? I'll bring idea of centrifugal force. So person B, there is a problem. What is that? He just said friction is acting. That's all. So for person B, so person B will write the equation. Person B. Person B, what it comes? Net force acting on block M with respect to person B is only frictional force F. Then what we do? We are going to introduce the idea of the centrifugal force. So this will be that one. So for person B, what happened? We'll bring a centrifugal force. So what action I should show centrifugal force? So here we'll take a diagram one. There's a thing. So there's a block. There's a top view. What I'm drawing is a top view. There's a radius R. Is a person B is standing here. Then what is notices? There's a friction is acting. Then we are going to introduce a centrifugal force m omega square. And how it should be? It should be perpendicular to the axis. There's a top view, or sir, like a show side view. The side view will be like this. Anything, the diagram, there's the axis about which the platform is rotating. This you can really try the with plate. You keep some vegetable which can be attached on the plate. Then what are the forces that I should show? A friction. Then what direction the pseudo force? The pseudo force should be in this direction. M omega square R. Got the idea? This will be. So now what person B, what you should write? This is what? Centrifugal force. Friction is not centrifugal force. With respect to person B, what is the equation? You can write it now. F minus m omega square R 0, or F minus. You should not write F equal to m omega square R for the person B. Person B, now can you give reason? What is the centrifugal force is acting radially outward? That is balanced by the friction. But this is what we imagine. We brought it. And what is the method of taking centrifugal force? It should be directed normal to the axis. It should be directed normal to the axis. You can see that this is the axis, no? And our centripetal force, centrifugal force is directed normal to the axis. Getting this one? It is directed normal to the axis. Mass of this system into square of angular speed into perpendicular distance of the system from the axis. So there's a method of getting the centrifugal force. And now, when do this centrifugal force will come into picture? When person B, if you are describing the motion of the block with respect to non-inertial frame, you have to bring it. A person, now look at the equation. Sir, both are same. You are writing F minus m v square by R. Here also what is there? F equal to, with respect to A, no? Both are same, no? Yes, both are same. That's what happened in laws of motion chapter also. Both were same, no? So therefore, now what is the friction? It will provide centripetal force. Are you getting the idea now? What about your friction? Here in this frame, friction, the centrifugal force is balanced by the friction. So don't call this is centrifugal, this is centripetal. You are killing the total physics here. Centrifugal force cannot balance centripetal force. It's a wrong idea. The frames are different, no? Person B, a person can be on the disc and also on the ground. Can there be one leg on the disc and one leg on the ground? Not possible, no? The platform is rotating. Can the person be on the platform and also on the ground? Not possible. Either he should be on the ground or on the platform. So therefore, what is mv square by R? Is a centrifugal force. What about friction? It will balance it. Getting the idea? So here friction is not centripetal. mv square R is centrifugal. No, wrong idea it is. But sir, both I'm getting same answer. Yes, you can do a problem in any frame. You get the same answer. Now what we do is we'll keep on increase the angular speed of the platform, angular velocity of the platform. Then what will happen here? If I keep on increase angular velocity, centrifugal force will also increase. Then the friction acting will be static. It will also increase. So then there's one upper limit is, no? What is that upper limit? Mu s mg. So when the block starts slipping on the platform, when the block will start slipping on the platform. So here I'll keep on increase the angular velocity